Hi guys, Assalamualaikum. So today we continue topic 4, analysis of variance. First, let's look at the introduction. Experimental design, denoted by ED, is the branch of statistics that deals with the design and analysis of experiments. In an experimental study, the variables of interest are identified. So we use the experimental design through treatments without changing any characteristics that we want to study. After a certain time, the measurement will be measured and draw some conclusions based on the observation of any change. So, experiment, investigator controls one or more independent variables. Then, the experimenter will observe the effect of independent variable on dependent variable. So, let's look at the difference between systematic experiment and randomization experiment. So for systematic experiment, when we lay out the experiment systematically, so this type of experiment not very good, but sometimes we need it. For example, we apply 4 different fertilizers A, B, C, D and replicate 4 times. If there is slope in the field, we will get biased result. So this one example of the result ABCD, 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 ABCD replicated 4 times. Meanwhile, for the randomization experiment, so to set up this type of experiment in a deliberately random way in order to enhance the statistical validity of any results obtained. For example, the experimenter used completely randomized design, CRD. So this type of experiment, space and time should not be bothered. So for example, apply for different fertilizer and replicate 4 times. This one, the result that may be obtained. ADBA, CBAB, ADCC, and DCBD. Next, let's look at the terms in ED. First, experimental unit is the object on which a measurement is taken. Second, factor. So factor is an independent variable whereby the values are controlled and varied by the experimenter. Third, a block. So a block is a source of undesired variation in the dependent variable. So this one known as a potential nuisance variable. Number 4, a level is the intensity setting of a factor. Next, a treatment, a specific combination of factor levels. And last one, the response here is the variable being measured by the experimenter. So this one, how to design the experiment. First, you must know the experimental unit. Next, what is the treatment? Number of replication. And last one, the experimental errors. Now we proceed to analysis of variance, commonly known as ANOVA. So ANOVA is a statistical technique used to test whether the means of at least 3 populations are different or not. So let's say you have 1 population or 2 populations. So we will use Z-test or t-test. So we will use variance. Why? Because of the observation based on one sample from each treatment group, and the means may be slightly different. So how different is enough to conclude population means are different? So this one depends on variability within each population. Means that higher variance in population means higher variance in means. Therefore, statistical tests are conducted by comparing variability between means to variability within each sample. So there are three assumptions of a one-way ANOVA. So first assumption here is the population from which the samples are drawn normally distributed, or at least approximately normally distributed. Second assumption here is the populations from which the samples are drawn have the equal variances. And last one, the samples drawn from the different population are random and independent. CRD. So experimental units are assigned randomly to treatments. CRD compares two types of variations to test equality of means. Next, comparison basis is a ratio of variances. Third, if treatment variation is significantly greater than random variation, then means are not equal. And last one, variation measures are obtained by partitioning total variation. Okay, so now we proceed to how to conduct a hypothesis testing of CRD. So there are 5 steps of hypothesis testing for CRD. First step, perform the hypothesis, null hypothesis and alternate hypothesis. So for null hypothesis, which is denoted by H0, so let's say 3 populations, mu1 equal to mu2 equal to mu3. If there are 4 populations, mu1 equal to mu2 equal to mu3 equal to mu4. Depends on how many the populations. Then the alternate hypothesis is at least one mean differs from the others. Second step, calculate the test statistics. So we will calculate F calculation from the ANOVA table. Step number 3, find the critical value from the F table. When we calculate F calculation, we will find the critical value from the F table. So F table here based on given alpha, first degree of freedom k minus 1, second degree of freedom n minus k. Next step is make a decision. So we will reject H0 if and only if F calculation greater than critical value. And last one, of course, we will make a conclusion. If you are given the mini-tab output, so you will make a decision based on the p-value. So the decision is reject H0 if p-value less than alpha value. So how to construct ANOVA table? So first step, look at here, source. We have factor, error, and then total. Second column is degree of freedom. K minus 1 and minus K and minus 1. So K number of factor levels. Meanwhile, n is sample size. Third column here is sum of squares. So sum of squares we will calculate based on factor, and then sum of square of errors, and last one total sum of squares. Next is calculate mean square. So there are two values, MSA and MSE. So MSA calculated from SSA value divided by degree of freedom for factor, which is k minus 1. Meanwhile, MSE calculated from SSE value divided by n minus k. And last one here is calculate F statistics or F calculation. So F calculation calculated from this value, MSA divided by MSE. So how to calculate SST, SSA and SSE? So first of all, we will calculate the correction means. So correction means all value add up and then square, divide by sample size. Next, how to calculate SST? So each of data square, add up, minus correction mean. Then SSA. So SSA, total of each treatment or each factor level squared divided by its sample size. Then add up for each level minus correction mean. And last one here is SSE. So SSE equal to SST minus SSA. Let's look at first example. In an experiment to determine the effect of nutrition on the attention spans of elementary school students, a group of 15 students were randomly assigned to each of 3 meal plans: no breakfast, light breakfast, and full breakfast. Their attention spans were recorded during a morning reading period and are shown in the following table. Assume that the required assumptions for an ANOVA test are satisfied. Do the data provide sufficient evidence to indicate a difference in the average attention spans depending on the type of breakfast eaten by the students? Use 5% level of significance. So this one, 3 population. No breakfast, light breakfast, full breakfast. 3 populations means that we will use ANOVA, analysis of variance. So to perform this hypothesis testing, of course, first step, set up the H0 and H1. So H0, mu no breakfast equal to mu light breakfast equal to full breakfast. Meanwhile, H1, at least one mean differs from the others. Second step, calculate F calculation or F statistics. So to calculate F calculation, we need to construct ANOVA table. First step, calculate total of each treatment or each factor level. No breakfast 47, light breakfast 70, full breakfast 65. Second step, n equal to 15 means that sample size or number of data 15. Then sum of x. So xij Sum of xij equal to 182. So 182 calculated from 47 plus 70 plus 65 equal to 182. Next value here is sum of xij squared. Means that each of data 8, 7, 9 up to 15, 12. Each of data squared and then add up. So 2338. Then we can calculate the correction means. So the correction means here is 182 squared divided by number of data. Calculate SST. So SST here 2338 minus correction means here equal to 129.73. Next value is SSA, means based on factor level. So we have 3 different or 3 factor level. No breakfast, 47, right? So 47 squared divide by number of data of no breakfast equal to 5. 1, 2, 3, 4, 5. Then second level, like breakfast, 70 squared divide by 5. And last one here is full breakfast, 65 squared divide by 5 minus correction means here equal to 58.53. Then calculate SSE, sum of square error. So 129 SST minus SSA equal to 71.20. Next step, construct ANOVA table. Degree of freedom 2. So 2 means that 3 levels. 3 minus 1 equal to 2. Total, how many sample size? 15. So 15 minus 1 equal to 14. So degree of freedom for error, 14 minus 2 equal to 12. So when you check, 2 plus 12 equal to 14. Next step, substitute SSA, SSE, SST. Then calculate MSA. So MSA 58.53 divide by 2. Then MSE. So MSE 5.93. How? 71.20 divided by 12 equal to 5.93. And then last one. Last calculation here is to find the F statistics or F calculation. 4.93. How? This one based on MS values. 29.27 divided by 5.93 equal to 4.93. So this one step by step how to construct ANOVA table. Okay, so third step of hypothesis testing is to find the critical value using F table. So using F table, what is the significance level? 5%, so 0.05. Then degree of freedom 2 and then 12. So from the table 3.89. The decision here is reject H0. Therefore, at 5% level of significance, the data provides sufficient evidence to indicate there is a difference in the average attention spans depending on the type of breakfast eaten by the students. Now we proceed to second example. So this one we will use mini type output to solve the question. Okay, so here the ANOVA table, and then this one P value, F value or F test, MS values, SS values, and then this one degree of freedom. Assume all assumptions of ANOVA are met. Do the data present enough evidence to indicate a difference in the average of particulate matter for the three countries? Test at 5% level of significance. So first step, set up the null hypothesis and alternate hypothesis. So null hypothesis mu A equal to mu B equal to mu C. Then H1, at least one mean differs from the others. Second step, P value equal to 0.020 here. Then step number 3, alpha equal to 0.05 here. 5% equal to 0.05, and then make a decision. So therefore reject H0 because P value less than alpha. So as a conclusion, at 5% level of significance, the data provides sufficient evidence that there is a difference in the average of particulate matter of the three countries. Example 3. So this example gives the data and also the mini-tab output. Let's try to answer question A. State the factor and the response variable. So what is the factor and what is the response variable? So look at here. An experiment was conducted to determine the effect of using three different types of adhesive on the strength of corner points of furniture. So factor is type of adhesive. Meanwhile, the response variable is bonding strength. Here, the bonding strength. Next question, question B. Determine the value of 1, 2, 3, 4, and 5. So 1 here, 2, 3. So 1 based on degree of freedom. So factor, how many factor level? 1, 2, 3. So 1 equal to 3 minus 1. Therefore 1 equal to 2. Next, number 2. Error and then total of degree of freedom. So this one is factor level minus 1. And then this one, number of data. How many data? From here till last data, 13. Therefore, number 3, degree of freedom. 13 minus 1 equal to 12. And last one here, 12 minus 2 equal to 10. Next, for here, sum of squares of error. So SSE calculated from here. 222 minus 143.70 Therefore, number 4 equal to 78.3. And last one here. Number 5. So number 5 calculated based on MSA divided by MSE. Here, divide 71.85 divided by 7.83. Therefore, 9.716. Next question C. Task at 5% significance level to determine whether the type of adhesive affects the bonding strength of corner points. So you must use 5 steps. Okay, so given the mini-type output, you can use this value, the P value here. Question C. Test at 5% significance level to determine whether the type of adhesive affects the bonding strength of corner point. So look at the mini-type output. The P value here 0.000. Therefore, you can use the P value to perform the hypothesis testing. So first step, set up the H0 and H1. So H0 mu D3 equal to mu D4 equal to mu C19. H1 at least one mean differs from the others. Then state the P value equal to 0.000. Next step, what is the alpha value? 5%. So 5% 0.05. So what is the decision? Reject H0. Why? Because P value less than alpha. So as a conclusion, at 5% significance level, there is evidence that the type of adhesive affects the bonding strength of corner points. Okay guys, that's all about the analysis of variance for the first part. Assalamualaikum.